As we have gone through all the important details related to writing basic SQL queries as part of this section or chapter, let's understand how to put these skills in practice to solve the problems like daily product revenue. Before getting into the details, first we need to prepare the tables. We got the scripts and we have executed the scripts which took care of creating the tables that are part of RetailDB along with loading the data into the tables. Then when it comes to problem statement daily product revenue, as final output, we want to project date, product ID, product name and revenue. Product ID is optional, however, there might be a scenario where the names might be repeated as part of our products table. To get correct results, we might want to use even product ID. If you do not use product ID, if there are multiple products with same name, then we'll start getting incorrect results. Now, when it comes to these fields come from multiple tables. For example, order date comes from orders, product ID can come either from order items or products, product name comes from products. When it comes to product revenue, it's a derived field and the source field for this comes from order items, which is nothing but order item subtotal. As we understood that the data for these fields comes from multiple tables, we have to apply join conditions across all the three tables. And also when it comes to revenue, we are only interested in complete or closed orders. Other orders which are in pending or on hold or cancelled, they do not add to revenue. That's why we want to skip those things. And hence we want to filter only for complete or closed orders using order status from orders. So even order status is required as part of our query, especially to filter the orders for complete or closed. Once we join all the three tables and apply filtering, we can group by order date, product ID as well as name. Then we can actually come up with revenue for each day for each product, and we can actually project whatever fields we want to project, which are nothing but date, product ID, product name, and then aggregated revenue like this. So as part of the select clause, this is how it will look like. Order date comes from orders, order item product ID, I am actually sourcing it from order items. You can also use products product ID in place of order item product ID because both of them mean same. Product name is only present in products, that's why I'm saying p.product name. P is nothing but alias for products, and then product revenue, which is nothing but alias for our aggregate function sum on top of order items subtotal. As part of the from clause, we have join between three tables. First between orders and order items on o.order ID and oi.order item order ID. O and oi are nothing but aliases for orders and order items respectively. Once we join orders and order items, then we have joined products using product ID from products and order item product ID from order items. Then as part of the where clause, we have applied the filter condition for order status in complete or closed. Then we have grouped the data by order date, product ID and product name. This will actually give us the results with respect to daily product revenue, where we are able to see not only the date, ID, but also the name of the product along with the revenue. Now if you want to just sort the data by date and then revenue in descending order, this is how the query will look like. If you want to get the number of records with respect to daily product revenue, this is how the query look like. Whenever you have group by, if you want to get count, you have to nest the query like this. So this is a nested query. For nested queries in PostgreSQL, you have to have the alias. So Q is alias for this nested query, and then we can actually get the count of our daily product revenue output, which is nothing but 9,120. So this is how you can actually put all the skills that are acquired to write basic SQL queries in practice and solve problems like daily product revenue.